Hello student, in today's lecture we will learn some point related with the unit 1, that is introduction to Unix or Linux kernel. So in previous lecture we started the processing environment. So this is the one point from that is the user perspective. So this is the simple program which creates a new process to copy the file. So first here we declare the main function main argc comma argv int argc char star argv. So this is the old type of declaration of a main. Then the open curly bracket. So here it is the start of the main function. This is the comment. Assume two arguments. So here there are two arguments, a source file and the target file. Then next statement is if fork is equal to 0. Now here we create the new process with help of the fork system call. And if the child process is created successfully, then it returns the 0. So here we compare the return of the fork with the 0. So if our new process is created successfully, after that we will call the execl. So execl call overlaps the address space of the child process with the file copy. So here in execl we execute the copy command and we pass the two arguments argv of 1 and argv of 2. So now if execl is succeeded, it never returns because the process execution or process is executed and the new address space is allocated to the process. Now the parent process will return the non-zero value, and so that it will call the wait. So here if here due to the wait, the parent process will wait to child complete. After that, the parent process will print the copy done. So this is, in this way we can use the fork system call, execl and wait system call. Now here we use the shell, and the shell allows the three type of a command. The first command can be an executable file which contains the object code produced by the compilation of the source code. For example, C program file. Okay, C program. So here, when we give the ./a.out as a command, at that time that contains the object code and which will be the executable file. Then second is a command, and that can be the executable file that contains the sequence of shell commands line. Okay, so second type of command, again it contains the executable file, but that executable file don't contain the object code, it contains the list or sequence of the shell command lines. And third type of the command is the internal command, and it makes the shell a programming language in addition to a command interpreter and include the commands for looping. Now next is the third feature, the building block primitive. So there are two types of the primitives, redirecting the input output and the pipe. So processes conventionally have access to the three types of a file. They read from their standard input file, they write their output into the standard output file, and they write the error messages to the standard error file. So each and every process can use the three files: standard input, standard output, and standard error file. Now next building block primitive is the pipe. So the pipe is a mechanism that allows a stream of a data to be passed between reader and writer process. So this is nothing but the communication mechanism between the two processes. So processes can redirect their standard output to a pipe and to be read by the other process that have redirected their standard input to come from the pipe. So what it's meaning? So suppose there are two processes. So one process can put their output into the file. That means redirect their output into the pipe. Then the other process can take the input from that pipe. Okay. So the pipe, what it will do? The output of a one process can be the input to the other process. So that can be happen with help of, that can be possible with help of the pipe. Now the data that first processes right into the pipe is the input for the second process. Then the second process could also redirect their output and so on. That means second process output will be put into the pipe and third process will take that as an input and so on, depending on the programming need. Again, the processes need not know what type of a file their standard output is. So they work regardless of whether their standard output. So output can be a regular file, can be a pipe or a device. Now next point is the operating system function. So we know that there are different functions of the OS related to the process management, related to the memory management, and related to the file management. So in a process management, it can create the process, it can terminate, suspend, and it can perform the inter-process communication. Now there is a CPU scheduling also for the multiple processes in the time shared manner, and in a memory allocation, either by swapping or paging for the executing processes or process. Then file input output will be there by creating the file system, and it insulates the processes from hardware of the machine. Next point is the assumptions about the hardware. Now we know that process is nothing but the program in the active mode or a running program. So program, that means the process can runs in the two modes, kernel mode and user mode. So basically what is the kernel mode? So when a process makes a system call, then it is said that now the process is running in the kernel mode. Okay, so when our process starts, it will be in the user mode, and when it calls a particular system call, that will be now into the kernel mode. Now user mode, when the process is doing the operations like assignments, comparison, looping, then it is said that now the process is running into the user mode. Okay, so now in this diagram, the A process is running in the kernel mode, B process is running into the user mode, C is also running in the user mode, and the D process is running into the kernel mode. So they can shift the modes according to their need. Okay. Now next point is the interrupts. So while handling the interrupts, kernel gives the first preference to the high priority interrupt and then to the low priority interrupt. Okay, so interrupt means what? When a particular event occurs, at the time interrupt will be generated. So when interrupt generated, what happens? The kernel will stop its current process and it will service the particular interrupt. And after servicing, it will again resume its execution. Okay. Now, how the interrupts will be services according to the priority. So first preference will be given to the high priority interrupt. Now, this priority of the interrupt is decided by the hardware itself. So in a system, there are different type of interrupts. We know that there are software interrupts, hardware interrupts. So there are machine errors also, system clocks interrupts are there, disk devices interrupts are there, network devices interrupts are there, terminal interrupts are there, and software interrupts are there. So for the machine error, the high priority is there, and for the software interrupts, lower priority is there. Okay. Now next point is the exception. Exception is an unexpected event caused by a process. For example, addressing the illegal memory by using the pointer, then execution of unallowed instruction like dividing by 0, etc. So interrupts occur by the events which are external to the process, while exceptions occur in the middle of the process due to the code instruction. Okay, so interrupts, we know that when a particular event occur, external event occur, at the time interrupt will be generated. But when exception is generated, during execution of a particular instruction, exception may be generated. Then it is also said that interrupts occur between the two instructions and the exceptions occur at the instruction. Okay, so when there is illegal instruction, exception occurs, and between the two instructions, interrupt may be occur. Then for interrupt, system starts the next instruction normally after handling the interrupt, but for the exception, system handles the exception first and then either restart the same instruction. Next point is the processor execution level. So this is the level, it is set to the disk interrupt level. So this is the figure here. At the disk device, the that level is set. Then what is its purpose? Now when we set a processor execution level at to the disk interrupt, then only system clock and machine error interrupts are processed and the remaining all lower level interrupts are prevented. So to prevent the particular interrupts, the processor's execution levels are set. Then they are also set during the critical activity, and with help of that we can privilege some instructions also. Now next point is the memory management. So if a sufficient memory is available, then the kernel can assign the memory to the program's process by the method of memory management. And we can use the different memory management methods like swapping, demand paging, etc. This is the Unix system architecture. This diagram is the block diagram of the system kernel. Now here there is a user program. In a user program, suppose one system call is there, or a user program calls a system call. What happens at that time? That will be in the libraries. There is a library. Then after that, when user program calls the system call, at that time the system call interface will be there. Okay, and with help of that they can communicate with the system call. Now there are two types of the system calls: the file subsystem, the system calls related with the file subsystem, and the system calls related with the process control subsystem. Okay, now the file subsystem system calls like read, open, write. Okay, and the process control subsystems are also there. In process control subsystem, inter-process communication, scheduling, and memory management will be there. Then with the file subsystem, buffer cache is there, device drivers are also there, and the hardware control is there. Okay, so this is the kernel level. Then user programs runs in the user level, and when there is a system call, that will be shifted to the kernel level. Okay, now in a hardware will be at the hardware level. Thank you.